Hey everyone, a very warm welcome to Fun Learn with Dipti. In this video, we are going to discuss very important questions of NCERT textbook of chapter Electricity. I hope all of you are doing great and preparing very well for your exam. And be sure to watch this entire video. And if you like this video, please hit the like button and share it with your friends. Please subscribe my channel so that you can get more videos related to various chapters. Alright guys, let's go ahead and start it. First question, a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash is, these are the option that is given to you. So the piece of wire is cut into 5 equal parts. That means the resistance will be equals to what? It will be equals to R by 5, right? So R by 5. As it is in parallel connection, therefore equivalent resistance will be 1 by R dash equals to 5 by R plus 5 by R 5 times. We are writing 5 by R because 1 upon R by 5 will be equals to 5 by R. So plus 5 by R and one more time 5 upon R, which is equal to 25 upon R. That means 1 by R dash is equals to 25 upon R, or we can write it as R by R dash equals to 25, which is our answer. So 25 is our answer. Now the next question, question number 2. Which of the following does not represent electrical power in a circuit? So there are various options that is given to you. So we need to find out the formula for power. What are the various formulas of power? Let us check it out. First one can be written as P equals to VI, and also we know that V equals to IR. So we can put the value of this V in the first equation. Okay, so it will be IR into I. So that will be equals to I square R. Okay, now also we can write I equals to V by R, and we will put this value of I in the first equation. That means P will be equals to then V multiplied by V by R. We are just replacing the value of I. So this will be equals to V square by R. Therefore, IR square does not represent the electrical power. Now question number 3 is, an electric bulb is rated 220 volt and 100 watt. When it is operated on 110 volt, the power consumed will be. So P is equals to VI, and we can write V into V by R. We are replacing this R with V by R, and this will be equals to V square by R. Or we can write R equals to V square by P. Now we put the value of these two. Sorry, it is 220 whole square upon 100, and when we will solve it, 220 multiplied by 220 by 100, then this 0 will cancel out, and we'll get 22 multiplied by 22, which is equals to 484, and the unit will be ohm. Okay, we want to calculate the power when there is voltage of 110 volt. So 110 volt, and resistance is going to be the same, that is 484. Now we have to solve this. 110 multiplied by 110 and divided by 484. So 10s are 11 fours are and 11 fours are. Now again we can cut it. 11 fours are and 11 tens are. So finally we get 100 upon 4. So this will be equals to 25, and the unit of power is watt. So our answer will be 25 watt. So 25 watt is the correct solution for this. Okay. Now question number 4. Two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then connected in parallel in a circuit across the same potential difference. So the ratio of the heat produced in the series and parallel connection would be, and various options are given to you. So first let's take out the resistance when it is in series. It will be equals to R plus R. So this is equals to 2R. Now we'll find the resistance when it is connected in parallel. So 1 by Rp will be equals to 1 by R plus 1 by R, and this will be equals to 2 by R. Okay. Therefore we can write Rp equals to R by 2. Okay. Now we want the ratio of the heat produced. So ratio of the heat produced, this will be, let's suppose the heat produced in series connection be Hs and heat produced in parallel connection be Hp. So we can write the ratio as V square by Rs upon V square by Rp. So we can write it as V square by Rs and then multiplied by Rp by V square. As the potential difference is same, we can cancel out these two. So it will become Rp upon Rs. Therefore we just have to put the value here. You will get Rp is R by 2. So we will write here R by 2 and divided by Rs. So we can write it as divided by 2R because the value of Rs is 2R. So we can write this as R by 2 multiplied by what? 1 by 2R. So this R and this R will cancel out and you will get 1 by 4. So ratio of Hs by Hp, the heat will be 1 upon 4 or 1:4. Okay. So our answer, that is C, this is the correct one. Now moving to the next question. Question number 5. How is voltmeter connected in the circuit to measure the potential difference between 2 points? So we know that the voltmeter is connected in parallel. A copper wire has diameter 0.5 mm and resistivity of 1.6 into 10 to the power minus 8 ohm meter. So what will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? So this is our question. D here is 0.5 mm. It is given to us. Now we know that R is equals to D by 2, and which will be equals to 0.5 by 2. and the value of it will be 0.25 mm. Now this is not in its standard form. We will convert it into meter. So it will be equals to 0.25 into 10 to the power minus 3 meter. Now we will remove the decimal point. It will be equals to 25 multiplied by 10 to the power minus 5 meter. Now the value of rho is given to us, which is equals to 1.6 into 10 to the power minus 8 ohm meter. Here also we will remove the decimal point. It will be equals to 16 multiplied by 10 to the power minus 9 ohm meter. Now R is also given to us, which is equals to 10 ohm, and we have to find the length. Length is not given to us. So we know the formula R equals to rho L by A, and we can write it as L equals to R into A by rho. This is equals to R multiplied by pi r square by rho. We have just put the value of A, which is equals to pi r square. Now we will put the value. So R here is 10 and the value of pi is 3.14, and the value of R given to us is 25 multiplied by what? Multiplied by 10 to the power minus 5 by the value of rho, that is 16 into 10 to the power minus 9. So that will be equals to 3.14 multiplied by, oh, I have forgotten to write here square. So 25 square multiplied by 10 to the power minus 10 by 16 into 10 to the power minus 9, and this 10 we can write it as plus 1. So this will be equals to 3.14 into 25 into 25 is 625 by 16 into, here we will write the power of 10 to the power minus 10 plus 1, and this minus 9 will go up and then plus 9. So 3.14 multiplied by 625 by 16, and this will cancel out. So it will be equals to 122.7. So this will be in meter. So L is equals to 122.7 meter. Part of the question they have asked, how much does the resistance change if the diameter is double? So R is equals to rho L by A. This is equals to rho L by pi R square, which can be written as rho L by pi d by 2 whole square. This is equals to 4 rho L by pi d square. This is our resistance. That R is inversely proportional to the square of the diameter. So R will be inversely proportional to the square of the diameter. Therefore R dash, if D dash is equals to 2D, which is given in the question, is inversely proportional to 2D whole square. That means R is proportional to 1 by 4 d square, means r dash is equal to 1 by 4 times of that of r. So the value of r is 10. So r dash will be equals to r by 4 equals to what? The value of it is 10, no? So 10 by 4, that will be equals to 2.5 ohm, and this is your answer. If diameter is doubled, then the resistance will change 1 by 4 time of its original, and its value will be 2.5 ohm. I hope this entire video is very useful to you. And if you have got any kind of doubt in these questions, you can ask me in the comment section. I will answer it. Thanks for watching.